How are you, everybody who is watching this fantastic video? I'm very happy to have you today, and I would like to take this opportunity to welcome some local engineering students who are pursuing different degrees and ordinary diploma in different institutions of engineering. My name is Olenjolai. I'll be here to teach you about the beauty of fundamental practical electronics. And I thank God that I will be teaching you, but also I will be coaching you, and I will be guiding you practically about the concept that we are going to learn. Remember, our learning philosophy, we just have 3 parts. The first one, theory. The second one, simulation. The third one is practical. So let me take this opportunity to welcome all the physical students. I have some local students in this workshop. And also, let me take this opportunity to welcome all the online students who have joined us through our official YouTube channel or through different online platforms that give you the contents or these contents. So another thing that I want to tell you, I just have couples of announcements, then we are going to start our class. These contents I have been preparing for particularly for any beginner, ordinary diploma engineering student, or any beginner of bachelor engineering in electrical field. So these contents can help any student who is in ordinary diploma in electronics engineering, or any students who is in ordinary diploma in telecommunication engineering, or any students who is pursuing ordinary diploma in computer engineering, any students that pursuing ordinary diploma and bachelor degree in electrical engineering or mechatronics engineering, or let's say that it's communication engineering, or it's different fields of engineering, and especially related with electrical engineering, even renewable energy engineering, also just the electrical field engineering. So, but also these contents can help a secondary student, especially Form 4 graduate secondary students or a Form 6 graduate secondary students. So you can take this content especially if you have a passion in electrical engineering or in electronics engineering. So that is one. Number 2, I would like just to clarify to you at the beginning of this class, how can you ask a question? For more than 14 years that I've been in this industry of teaching, I love to give students a chance for them to ask a question. So for the online students who are watching this video, maybe on our official YouTube channel that's called Online Bachelor Polytechnics of Tanzania, _Mwl Olenjolai M, or Online Diploma Polytechnics Institute of Polytechnics of Tanzania, _Mwl Olenjolai. So you can ask a question by using the chat if this video will go live or is going live, or you can ask your questions on the comment section or at the bottoms of your left-hand side. So make sure that you ask a question. But again, in case that you've missed our previous workshop, this is workshop 4.5 today. Workshop 4.5. If you've missed workshop 4.1, 4.2, 4.3, or you've missed about workshop 3 or workshop 2 or workshop 1, don't hesitate to visit our official YouTube channel that's called Online Bachelor Polytechnics of Tanzania, where you can get those contents in the playlist that we call the Fundamental Practical Electronics Engineering. Or you can also access our contents in our online Diploma Polytechnics Institute of Tanzania or Polytechnics of Tanzania, _Mwl Olenjolai, in the playlist which is also called the Fundamental of Practical Electronics Engineering. So use the comment section to give us feedback. Use the comment section to ask a question. Later on, I will connect you with I will connect this program with the WhatsApp platform for you to share different information. So now, I believe that you are ready to take this class or to attend this workshop. We are still covering the concept of the theory. So, ladies and gentlemen, welcome to learn the modules of course that called the Fundamental of Practical Electronics Engineering. And we are in chapter 4 that called Resistor as a discrete electronics components. And this is workshop 4.5 that called the Resistor color coding. Resistor color code, that today's lecture. So take your exercise book, take your pen, take your pencil, take your ruler, and take your fresh mind and take your scientific calculator in case of the calculation, and take the fresh mind, and remember that in our online Bachelor Polytechnics Institute of Polytechnics of Tanzania, we have a philosophy, and this is the engineering philosophy that we call the mind. So you are training the mind and the hand. So our philosophy is mind and the hand. We are training our mind, and then we use our hands to implement what we have been training our mind. So if that's the case, let us go directly into workshop 4.5. So how are you, student? How are you, student? Okay, so let us go into the quick review. So before I teach you about workshop 4.5, let us spend some few minutes to do the quick review of previous workshop, and this is workshop 4.4. Workshop 4.4. So in workshop 4.4, the title or the name of the workshop is called the power what class? Power rating of a fixed linear resistor or of a resistor. Linear resistor of a resistor. Then we define what the meaning of power rating, right? So we say that what is the meaning of power rating? So power rating. If you don't know the definition of power rating, I offer the two definition and power rating of what? Of a resistor. So I offer the two definition. And we say that power rating is what? The maximum amount of what? The maximum amount of what? The maximum amount of power? You forgot. Okay, so I gave you two definitions of power. So actually, this is the maximum amount of current that a resistor can withstand without a damage. Right? That's the meaning of 40 power rating of 40 of a resistor. And then we say that we can classify resistors by using the power rating. So from there, I talked about the low power rating of resistor. Low power rating of 40 of resistor. And also, I classified again to you, or the second branch, it's what? It's a high power resistor, or high power rating. High power rating resistor. And example of this low power rating resistor is 0.5 watt resistor. And example of the high power rating resistor is a resistor with a power rating of, let's say, 20 watt. And then I told you about examples of low power rating resistor. And also I gave you some examples of high power rating resistor. Then I told you that the power rating of a resistor defines what? The power rating of a resistor defines what? So you say the power rating of a resistor defines what? Defines the size of what? Define the size of the resistor. Find the size of 40 of a resistor. Then I told you that low power resistor has what? Has small size. And I told you that high power resistor has what? Has large size. Large size. And then I told you that the power rating of resistor matters a lot in designing the PCB. Designing the what? The design the what? The PCB layout. Why? Because of what? Then I told you about factors. Factors that affect what? That affect resistor. But also at the end of workshop 4.4, I taught you about what? Some standard power rating. resistor or fixed resistor, because we are not talking about variable resistor. I will teach about variable resistor in intermediate level. Are we together? So that is the quick review of what we have covered in workshop 4.5. So let us go into today's concept. So students, say resistor. All the online and offline students, say resistor. Say resistor. You can write color in this way, or you can write color in this way. So this color is Britain English, this is American English, right? Should not be confused. Resistor, color, coding. Resistor what? Color what? Color coding. Say resistor, color coding. Most students are familiar with this concept of color codings on the small on the resistors, on the small or low power resistors. Most of the students or most people, they are familiar, but they don't spend much time to study them, and they don't spend much time actually to analyze them. Are we together? Are we together? So resistor, color coding. That's the title of today's subject. So before we define the meanings of resistor color coding, let us just illustrate where does it come from. Resistor color coding. So here it's a problem, or the origin. The values of resistance of low power fixed linear resistor. Linear resistors are not written. So now we are discussing the challenge that we identified in the previous workshop. Are not written on the resistors. So the values of resistance of low power fixed linear resistors are not written on the resistors. Is it true? This is the example of what? This is the example of low power. Or let's say that this is the simple example of low power linear fixed resistor, right? But when you check this low power resistor, there is no any label of its resistance on top of it. And that's why it has a color coding. While in case of the power resistors, you find that the power resistors, they have a label 40 of its measurement parameters, resistance and power. And that's why that this power resistor does not have color code. We'll discuss it in detail. So the values of resistance of low power fixed linear resistors are not written on the resistors. While the values of resistance of high power resistors is written high power resistors. is written on them. So the values of resistance for the low power resistor or low power fixed linear resistor is not written on top of resistor. But in case of full high power resistor, example this one, the values has been written. Okay? The values has been written. So because the value of resistance of the low power fixed linear resistors is not written, then we can identify, we can find the resistance of the resistor by two methods. In electronics, and the electrical engineering, there are two ways used to determine the value of resistance. Of a resistor. So in electronics and electrical engineering, there are two ways. There are two ways that are used to determine the value of resistance of a resistor. So namely, we can determine the value of resistance by using color coding, or by using a measuring instrument. So these are the two ways that we can determine the value of low power fixed linear resistors. The first one by using what? Color coding. The second one by using what? So these are the methods which are used to determine what? Resistance of low power what? Resistors. Are we together? Resistor color coding. So the fundamental question that we have here, what is resistor color coding? What is the resistor color coding? Try to answer the definition that you know and try to think about what you know. Okay, student, what is color coding? What is color? Not the color coding. In electronics and electrical, we have different aspects that we have to mention about color coding. For instance, we have a color coding for inductor. We have a color coding for wires. A live wire always worldwide, its color coding is red. And the neutral wire, its color coding is black. And also for the earth, its color coding is green and yellow, or green itself, or yellow itself. So when we talk about the concepts of the color coding, it's broad. That's why we are narrowing the concept that today in this workshop, 5.5, I'm going to teach you about resistor color. Resistor color. Class A, resistor color coding. So again, resistor color coding. So we have seen those amazing color, but possibly we have never thought about what do they mean. What the meanings of the color coding. Resistor color coding. What is resistor color coding? So you say resistor, because remember the problems I have analyzed. It means the need for us to learn. Why should we learn about the resistor color coding? I have shown the necessity here. That the values of resistance of low power, fixed resistors, are not written on the resistors. That's the problem. Right? While the values of resistance of high power are written, or is written on them, on top of them. Okay? So you say the values of resistance of the high power resistors are written, not is, are written on top of them. So are written, let's say that, on top of them. So we don't have, so the concept of the resistor color coding dealing with low power resistor only. It does not deal with the high power voltage. Why? Because in high power resistor, the resistance of that high power resistor has been shown on top of it, and its power rating has been shown. But remember that the concept of the color coding is just dealing with the measurement parameter of resistor that is called what? Resistance. These concepts of the resistor color coding does not deal with the power rating. Are we together? Are we together? Let me repeat. I say the concepts of the resistor color coding will teach you about how can you find or how can you calculate the resistance of of the low power resistors by using this color band. Are we together? So this concept will never help you or will never teach you anything about how you can calculate or determine the power rating of the resistor. Are we together? So make sure that you write those clear information in your mind. So in electronics, we say that the resistor color coding is the way. So this is the way. Is the way to find the resistance, to find the tolerance, class A resistance, say resistance, say tolerance, say tolerance, say tolerance, tolerance or tolerance, okay. And also, the concept of resistor color coding can help us to find the temperature what? Temperature coefficient. Temperature coefficient of the resistor. Temperature coefficient of what? Of the resistor. Oh, so now I get some other information. This concept will not only teach me how to find the resistance of the resistor, but the concepts of the resistor color coding will also teach me how can I find the tolerance of the resistor and how can I find the temperature coefficient of what? Of the resistor. However, that will be keeping our focus on how to determine what? Resistance. So simply, resistor color coding, it's a way of finding what? To find the resistance or tolerance or temperature coefficient of 40 of a resistor, of the resistor. So how can you use color coding to find resistance of the resistor? Stay tuned, I will teach you. How can you use the color coding to find tolerance of the resistor? Stay tuned, I will teach you. How can you use which resistors, which low power resistors, we can find its temperature coefficient? Stay tuned, I will show you. Many students, they know how to use color coding just to compute resistance. That's all. Are we together? So maybe possibly for these students who are physically in this class and even some online students, I know that possibly you know how to use the color coding in computing the resistance, but possibly you have never practiced it several times, because you have to practice the concepts of the color coding in such a way whenever you see this one, within 30 seconds, you can say this resistor has a resistance of FA2. You didn't hear what I said. Let me repeat. I say you have to do practice about using the concept of the resistor color coding to compute the resistance of the resistor in such a way whenever you see a resistor like this, you can use your brain to do the calculation and determine its resistance within 20 to 30 seconds. I know for you, you need just a paper, writing and whatever, drawing, because you didn't do practice. And why you don't like practice? Because you're a Bongoland people. So Bongoland people, whenever we understand the concept, then we say that we are professional. Okay, so this is the definition. So this definition, it's enough. It's enough. Then another concept, we say that, why do we need also to know the concepts of 40 of color coding? We say again another challenge is low power resistor, fixed linear resistor, low power fixed linear resistors are usually very thin. Say very tiny. Very thin or very small. It means that very thin. And it is what? So we are answering the question why the values or the values of resistance of the low power fixed linear resistors are not written on top of the resistors. ND, so you say that ND, it is, so ND, yes, ND, it is a challenge. It's a challenge to print resistance, values on them. So another problem or another challenging thing or challenging issue in low power fixed linear resistors, these low power fixed linear resistors are small, are very tiny, they are very small in size, right? So actually to print the value of resistance on top of it, it's a challenge. Okay? Values on them, it's a challenging. So that's why I say it's a challenge to printing resistance values on them. So if that's the case, so color bands are printed. So how the problem has been solved? We say that so color bands. Say color bands. Say color bands. So color bands are printed. Color bands are printed on them. Color bands are printed on them. Color bands are printed on them to present the electrical present the electrical resistance. Present the electrical resistance or present the electrical resistance. So the color bands are printed instead of the values. And the function of these color bands is actually they can help us to determine what the resistance of the resistor. Okay? And then we say that these color bands are known as resistor color codes. These color bands are also known as, so these are also known as resistor color code. Resistor color code. Resistor color code. Resistor color codes are the concept that you have to cover. Are we together, student? So I have shown the problem and I have shown the demand. Why do we need to learn the concepts of resistor color coding? Right? Remember we mentioned two ways. Most students, they like to measure or to identify, to determine the resistance of the resistor by using what? A ohmmeter. What if you don't have a ohmmeter? Or what if you got the interview and then you won't be given a ohmmeter? You'll be struggling, right? Okay. So if that's the case, we have also identified another what? Another vocabulary here. And this vocabulary is called what? Tolerance, right? So then let us understand what the means of tolerance, and then we'll get into what? We'll get into the concepts of the resistor bands, and then we'll go to the concepts of the color bands. Okay? So then let us just discuss this terminology that called the resistor tolerance. Class A resistor tolerance. Again, class A resistor tolerance. Say it loudly. I say it loudly. Those are the students that I have in this class. Say resistor tolerance. Again. Remember, if you pronounce these terminologies, then those terminologies will be written in your mind. So what is resistor tolerance? Say resistor tolerance. Say resistor tolerance. So there's a different way that you can define this terminology, but this is the one of them. Resistor tolerance is a measure. So this is the measure. Is the measure of the resistor's variation. Resistor's variation. Resistor's variation from the specified resistive value. Specified resistive value. From the specified resistive value. Resistive value, and in consequence, is a consequence of the of the manufacturing process. The manufacturing process, and is expressed as a percentage of its normal, of its nominal. Of its nominal or preferred value. Class A resistor tolerance. Stop writing, listen and watch. Physical student and the online students, stop writing. Listen and watch. Don't slumber. A resistor tolerance is the measure of of the resistor's variation from the specified resistive value, and is a consequence of the manufacturing process. And this one is expressed as percentage, say percentage of its nominal or preferred value. Listen carefully. In workshop 4.3, I taught you about the standard resistor, right? Standard resistor. And I told you that in electronics and electrical engineering field, the engineers, they don't make any value of resistance. They don't make resistance with any value. Do you remember that? Do you remember that concept that I taught you? So in case that maybe you need a value which is not standard, which is non-standard, you may take 2 or 3 resistors and connect them either in series or parallel, or both series and parallel connection. Are we together? But sometimes you might find that the value of the resistance that you wanted to use in your project, it's near to the standard resistor. From there, we say that, okay, let us take this nearby standard resistor. Why? Because of the concept of the tolerance. Tolerance, simply we say in measurements, it's acceptable error. Say acceptable error. During your advanced secondary education, you learned the concepts of error in A level. It's a first topic in mechanics. Right? We dealt how to add the errors, how to subtract the errors, how to multiply errors, how to divide errors, and we use as always to apply logarithm, ln of something. Do you remember those mathematics behind? We learned about what percentage error. We learned about fractional error. You forgot them. Those information are very important for the practical context. So it means resistor tolerance, in other words, we say this is the acceptable error. When you say acceptable error, it means when you have a standard resistor, which is resistance is 100 ohm, right? 100 ohm. So that resistor must have a tolerance, an acceptable error. It means we say this, the standard is 100, it's middle value, but this resistor, it can be measured and the resistance being found at, it's 97 ohm, right? Or it can be measured and found its resistance is 103 ohm. Okay? So it means that the variation from 97 ohm to 100, Fatuma, you're not concentrating, and the variation from 100 to 103 ohm, that's what we call resistor tolerance. Let me just explain to you practically. So we say that, so this the resistance is the measure of resistance variation. Say resistor variation. Remember we are learning about fixed resistors, which their values are not varying. But when they make it, there's no any way to make a resistor which is resistance is 100 ohm. Right? And we'll realize this one in this week or in the next workshop when we know that this resistor, according to the manufacturer, he said its resistance is 100 ohm. But when we measure, we'll never find 100 ohm. We might find the value less than 100 ohm or the value which is greater than 100 ohm. So you can ask yourself, you can say, okay, this resistor does not have a resistance of 100 farad, concentrate. Are we together? Are we together, class? Let me just simplify this concept. Let me give you some few examples for you to understand, and even for the online community. Examples. Example, we say that, let's say, example, we can have a resistor, okay, resistor of resistance of 220 ohm. 220 ohm with tolerance of 40 of plus or minus 5%. So I'll give you its range. This is one of the example. Then we'll have a second example. Or let's just deal with this one first before we go for the second example. Stop writing. We can have in electronics, we have a resistor whose resistance is 220 ohm. Do you remember that? It's a standard, right? And its tolerance, it's plus or minus 5%. Because it's a resistance, so it means that a resistor tolerance is the measure of the resistance variation from what? From the specified resistive value. Where that specified resistive value, 220 ohm. Right? And then so what we say that, and it is a consequence of the manufacturing process. So what does it mean? It means the manufacturer is the one that decides about the resistor tolerance, not you, the user. The manufacturer is the one that manufactures the resistors with their tolerance or tolerance. Are we together? And then manufacturing process is expressed as what? Percentage. Say percentage. Say percentage of its value, of its nominal or preferred value. So you see the percentage. Okay, so listen and stop. Let me clarify what does this concept mean. Simply we say that the measured value, this 5%, it's acceptable error. It's acceptable. So let us think mathematically. Let me explain this concept to you mathematically. Remember that 5%, ladies and gentlemen, this is equal to 5 over 100. Do you agree? Then 5 over 100 is equal to 0. 20, add 0. 50 over 100 is still 0. Then add 0. 500 over 100 is equal to 5. Are we together? So the resistance of this resistor, will be 220 plus or minus 0.05 what? Ohm. Remember that in science, whether physics science, whether biological science, whether chemistry science, whether environmental science, whether engineering, any field of engineering, we say that any measured value without the acceptance or acknowledgement of the acceptable error is meaningless. Are we together? What does it mean? It means in engineering, if you say, I measure the resistance of the resistor and I found 220 ohm, that is meaningless. It does not exist. That is not a measured value. Why? Because you did not include what? The acceptable. Are we together? In A level, you learned the topic of error, and this is familiar, but you learned how to solve questions. But you've never learned how to use it in real life. So what the meaning of this one? This is wonderful. Then we go for the mathematics of the inequality. What does it mean? It means that resistance of this resistor, it has these values. So we have 220 plus 0.05 and 220 minus 0.05. So the smallest value is this one. It means the resistance of this resistor lies between 220 minus 0.05, then we close the bracket, ohm. This is less than or equal to resistance, and this is less than or equal to what? 220 plus 0.05. 0.05 ohm. Are we together? Are we together? So if this is the case, you say that 220 minus 0.05, yeah, you are going to get your 100, 119, point 2095. Is it? Yeah? 200 again. Yes, 219. Thank you. 219. Like, ohm. This is less than or equal to resistor, and this is less than or equal to what? And this one will be what? 220, 25. 25 what? Ohm. So it means the resistance of this standard resistor of 220 ohm will lie between 219.95 ohm and the 220.5 ohm. 05. Thank you very much. 220.05 ohm. So listen. Then you go back to mathematics. I told you that engineering is all about what? Numbers, formula, and the equation, diagrams, tables, and what? But remember that in engineering we apply mathematics. If you go, you refer mathematics and especially that probability, the topic that called what? Probability. This is a continuous random variable. So if it's continuous random variable, here we have millions values of resistance of that resistor. Because it means that if you measure the resistance of the resistor of 220 ohm and you find it range within this value, that value is correct. Hello? Hello? Is it clear? So for instance, if I already measure the resistance of this resistor and then find that it's 219, or let's say that it's 219.96, and also Ruben measured the resistance of the same resistor and found that it's what? It's 220.01 ohm, and also Good Luck measured the resistance of the same resistor and found that it is 219.999 ohm. And then comes the question, who is correct? And then Fatuma, our sister here, also did the measurement and found that the resistance of this resistor, it's 220.04. Then the question comes, which value is correct? All the values are correct. Why? Because they are within the range. Electronics is beautiful. Oh, I made a mistake. I made a mistake there on that tolerance. I made a mistake. I'm sorry. I made a mistake. I made a mistake here. Let me correct that mistake. I made a mistake. I deviated from the truth of the definition. Remember, the definition said that is expressed as percentage of its nominal or preferred value. That's why I was wondering why this error is very small. So the mistake I made is this one. The good thing that you did not write, because I told you that listen and watch. Had the advantage of listen and watch. But if you could have written here, we could have already finished the word. Okay. So this is the concept. To get this one, so we said, as I said, that actually that this the resistor whose resistance is 220 and tolerance is 5%. Say 5%. So resistor tolerance there is 540. 540. So it means that the resistor is 220 ohm, and the resistor tolerance for this case, tolerance, the resistance tolerance, it's 40 plus or minus, or it is 5%. Plus or minus 5%. So listen, how do we represent this one? We say this one. Look, this is the formula. So he said that the actual value or the measured value of resistor will be what? 220, or it means that this is the formula. Let's say that R1, stop writing. This will be equal to R plus or minus the tolerance. It means that we say, let's say 5% of R. Right? What does it mean? We say that if we wanted to find the range of that resistor, we say that, how can we get this error? The tolerable error. So the tolerable error, we get that from what? Because this one we call it change in error or change in resistance, for instance. So change in resistance for this case is equal to what? 5%, which is 5 over 100 times the resistance, which is 220. What do we get? This 0 and this 0 cancel. Then we simplify by 2, 11. By 2, 5. Right? What do you get? This is 11 ohm. Okay? So now, the resistance of this resistor, I said stop writing. The resistance of this resistor, the tolerable error is 11 ohm. Okay? 11. So the resistance of this resistor is equal to what? 220 plus or minus 11 ohm. Hello? Are we together? Are we together? So this value also we may write like this way in terms of inequality. We can write that this is equal to 220 minus 11 ohm less than or equal to R less than or equal to what? 220 plus 11 ohm. Are we together? So the range of this resistor will be what? 220 minus 11. Fatuma? 209. Right? Then less than or equal to what? Resistor R. Then less than or equal to what? 231 what? Oh. So listen. Stop writing and watch. If Reuben measured the resistance of this resistor and found it is 210 ohm. Also, we have Fatuma measure the resistance of the same resistor, and her measurement is actually 212 ohm. Then also we have Farid measure the resistance of that resistor and found that its resistance is 229 ohm. And then we have also Good Luck who did the measurement, R4 for instance, and then his measurement is 226 ohm. Then the questions come, who is correct? All of them are correct. But if Olenjolai measured the resistance of the same resistor and found it is 200 ohm, then Olenjolai is wrong. This is correct. So in the concept of the tolerance, you see that even the value of fixed resistor extend. Hello? That's why whenever that you have done your calculation and found that maybe the calculated resistance of the resistor that you want to use, it's 225 ohm. There's no need for you to think about series and parallel connection. You just want to take a resistor which is its standard value is 220 and then make sure that the tolerance cover this. Hello? Are we together? So when somebody challenges you in your design, the resistance of the resistor is 225. Why did you use 220? Then you tell him or her, it's because of the condition or factor of 40 resistor tolerance. So even 225 ohm, I might get it from 220. So do you see the ignorance of tolerance? How does it affect you? Because actually you find that here we are using a resistance of 1 kilo ohm. Why 1 kilo ohm? Class, are we together? Are we together? So let me give you a second example and then let us move forward. I think the class is interesting, isn't it? Do you like color coding? Do you like resistor color coding? In your dressing, do you used to follow the color coding? Dressing code? So second example. a resistor of 1 kilo ohm with resistor tolerance. With resistor tolerance of what? With resistor tolerance of 10 plus or minus 10 ohm. 10%, sorry. Okay? So let us start this one. Let's understand the concept of tolerance. So what the tolerance of this resistor? 10%. Plus or minus 10 what? And then what is the standard resistor? 1 kilo ohm, which is equivalent, which is equal to what? 1,000 ohm. Okay? So let us clarify and let us learn the concept of tolerance, right? Are you ready for that? Stop writing. Look. So firstly, we have to think how we can write it. So firstly, we say that calculate that value of tolerance. So I told you that we say that resistor, let's say resistor is equal to what? So a resistor is equal to a resistor or resistance 1. Resistance 1 is equal to resistor plus or minus percentage of tolerance, which is 10% of resistor. Oh. Right? So then let us compute the tolerance. So you say resistance of the tolerance is equal to what? 30% of its value. 10 over 100 times 30, 1 kilo ohm, which is 1,000 ohm. Hello? So here we are cancel to 0, to 0. What the tolerance? So resistance tolerance is what? 100 ohm. Good luck. 100 what? Oh. So is that the case? How can we write? Look, stop writing. So this one means resistance of this resistor. We can write as what is R? 1,000 ohm plus or minus 100 ohm. It means that the tolerable error of this resistor is 100 ohm. Are we together? Or in other words, we can also write this one as what? 1,000 minus 100 ohm less than or equal to R. Less than or equal to what? To 1,000 plus 100 ohm. Are we together? I said stop writing, listen and watch. So 1,000 minus 100, good luck. Good luck does not know. 1,000 minus 100 less than R. Farid, 1,000 plus 100. 1,001 what? 100. So this is the range of 1 kilo ohm. Right? So whenever you do the measurement or you measure the resistance of the resistor and find in between 900 ohm and 1,100 ohm, your measurement is accurate. This is the hidden secret of resistor. I'm going to demonstrate this concept in this week and you'll get surprised. Are we together? And remember that this is the practical. Whenever that to get the range of these values, should be measured the values. Remember the color coding, listen. The color coding gives us the standard resistor, the value of standard resistor, the value of the standard resistance, or the value of, yes, the value of the standard resistance, and the tolerance. Right? But color coding does not give us this range. We have to compute to know. So for this,